Good morning, students. Yesterday, I started with the structural testing. In the last class, I explained why do we require the structural testing, and I explained with the example of the program that was the CGI code for conversion of the string into the plain text that I was explaining with the for the structural testing. Right. So, what is the purpose of using the structural testing? To test the thoroughness of the program based on the structure of the program, and the structural testing is also known as the white box or glass box or code based testing. And structural testing was used to distinguish from the functional requirements such as the black box testing, because black box testing mainly concentrates on the functional testing. So to distinguish from the functional requirements, we are using the structural testing. And the structural testing is still testing product functionality against its specification. This I discussed in the last class itself. And why we are going, as I said, structural testing is also called as the white box, glass box, or the code based testing. So why we are going for a code based or the structural testing? Because when we are executing the program, if a part of the program is not executed by any of the test cases which are present in the test suite, then the faults cannot be identified from the program. Understood? Let us consider that you have implemented a program, and we have to test that implemented program. To test that, we are using the set of test cases or the test suites. And when we are executing the program by using these test cases, and if one of the statement or part of the program is not executed by using those test cases, then it is very difficult to identify the faults which are present in the program. Right. And here, when we are considering the program is a combination of a statement, branches, or the conditions, or the paths. So, right. So, in the structural testing strategy, we are testing the entire program either by using the statement testing, or the branch testing, condition testing, or the path testing. And we assumes that when we are using the structural test, different structural testing strategy, we assume that all the statements in the program or the entire program is going to be executed without leaving any single statement or the single or any part of the program. Right. So next you are going to study about a different structural testing strategies such as the statement testing, branch testing, condition testing, and the path testing. So in the last class, I have given this example, right? Conversion of the string from the translation of the string into the plain ASCII text. So this program I explained in the last class. So here we have number of different lines of codes are there. If one of the line of code is not executed, then the fault, if the fault is present in that line, then that is not going to be identified when we are using the functional testing. Right. So let us consider that in this case, if else, right? Else part is there in line number 34 and 35. Else part is there. If any of the test case where when we are using, if it not covering the statement or not executing this particular statement 34, then what we say that if fault exists in that particular line, then that is not going to be identified. That is the one case. And the second case is, let us consider in line number 31. It is star dptr is equal to 16 star digit I plus a digit low, right? In this, if instead of 16, if erroneously if I type it as just 6, then there is no syntax error in this particular statement, right? And that statement is also going to be executed, and we are getting the output, but the output is not correct. Why? Instead of 16 I typed it as 6, or instead of 16 if I type it as just 1, then also we are going to get the output. But the problem is, the whatever the output we are obtaining, that output is not correct. So these type of faults are not going to be identified when we are using the functional testing. And hence we are using the structural testing. In structural testing, we are concentrating on each of the strategy, that is statement testing. In the statement testing, we are going to test, or we are going to execute each statement in the program so that we can identify the faults. In the case of the branch testing, we are concentrating on execution of each branch. And in case of the condition, all the conditions which are present in the program are going to be executed, that we are testing with the help of the test cases. And in the case of the path testing, all the paths. So for performing the path testing, we are going for construction of the control flow graph for the given program. Then by using the control flow graph, we are going to check whether all the paths in the control flow diagram is covered or not. That we are going to check it. Okay, so here we are checking that if one of the statement or one of the line is not executed, if the error is present in that particular line, then that fault is not going to be identified. Such errors exist, then our main intention is we need to identify such errors, right? That's why we are going for the structural testing strategy. And then from now onwards you are going to study about different structural testing strategies. So before that, as I said, in order to test the developed program or the implemented program, we are using different testing strategies. Hence, the implemented program is written in the form of a control flow diagram. So see here, this is the control flow diagram, which consisting of the different blocks, consisting of different blocks, say here block A, B, C, like that. And whenever we are testing the program in the form of a control flow diagram, then we are going to identify whether each node is executed or not, or each branch is executed or not. That we are going to test. So here we are not concentrating on how we are written, how the control flow diagram is written for the CG. For this particular code or for this particular program. So we are just considering this control flow diagram, and we'll check whether all the nodes or all the branches or all the paths are executed or not. That we are going to test by using different structural testing strategies. So same thing as I said. So see here. So when we're using the control flow diagrams, as I said, executing all control flow elements does not guarantee finding the faults. So here we have the different control flow elements, right? In this we are having different control flow elements, and in this diagram also we are having different control flow elements. And executing all the elements does not guarantee finding all the faults. Then execution of a fault statement may not result in a failure. As I said, let us consider this statement here, or this particular one, right? It is there. Yes, in this block, see here, dptr is equal to 16 star digit I plus digit low. As I said, instead of 16, if I type it as a 6, then the syntactically this statement is correct, but whatever the output, we are getting the wrong output. Then in such cases our testing strategy should identify such faults, but it is not possible. So even though that statement is executed and we are getting the output, but it is failed to identify or failed to detect the fault statement. Why? Because this statement consisting of the fault value. Instead of 16, if I type it as 6, it's a fault value, right? Because whatever the value we are getting, that should be multiplied by 16 in order to represent it in the hexadecimal value. So that we are getting it as the wrong value. Or instead of 16, if I type it as 1, then also the syntactically the statement is correct, but it it will give the wrong output, and that is not identified through the execution of the control flow elements. So that is, execution of a faulty statement may not always results in a failure, because even that is a faulty statement, but the fault is not identified. We are getting the output, but the output is wrong, right? The state may not be corrupted when the statement is executed with some data values. As I said, that is the example. Corrupt state may not propagate through the execution to eventually lead to the failure. See here, in some cases what happens, okay, that is executed. Clear, this 16 is executed, but when we are using this value in some other calculation, there it may leads to the failure of the program or failure of the system. That is the case. Corrupted state may not propagate through the execution, and it eventually leads to the failure. So when we are using the structural testing, it increases the confidence in thoroughness of the testing, and it removes some of the inadequacies present in the form of a statement, a branch, or the path, etc. Okay, so by using the structural testing, we are removing the inadequacies and we are testing the thoroughness of the test cases which are used in the structural testing method. Okay, still. Then, as I said, the structural testing is used against the functional testing, because in the functional testing, we are testing the developed program against the given requirements. But there, if some in the functional testing, there is a chance that the entire part of the program is not going to be executed, and some part of the program is not at all executed. So such a scenario is avoided in the structural testing strategy. Okay, control flow testing includes the cases that may not be identified from the specifications alone. See here, before functional testing, what happens, or before the system development, what is the first step? First, we are going to collect the specifications or the requirements, right? Once the requirements are collected, then only the system is designed and it is developed, right? So once the system is designed and implemented, then only we can test that implemented program or the system, right? So simply just by the based on the given specifications and the system was developed, and that system cannot include the test cases that are identified from the given specifications alone. Because let us consider that implementation of a single item of the specification by multiple parts of the program. For example, a stable collision. So that is not visible in the program or in the system, or that cannot be tested by using the different test cases, right? So there it is very difficult to identify the faults also, because that is not clearly visible. So in such case, because that hash table implementation is done in multiple parts of the program, not in a single function or not in a single procedure that is implemented, because that hash table is implemented in different parts of the program, and that cannot be identified by execution of the single test case. And next one is test suits that satisfy the control flow adequacy criteria could fail in revealing the faults that can be caught with functional criteria. Let us consider this is whenever we are using the control flow strategy, there we have constructed the test suits, or we are using the test cases to satisfy the control flow testing strategy. But those test cases or the test suits may fail in identifying or revealing the faults that can be caught with the functional criteria, or that can be caught with the help of the specifications. But see here, control flow strategy is the different one, and the functional testing is another criteria, and we cannot make use of the same test cases to test the developed system. Okay, because whatever the test cases we have developed for control flow testing may not be suitable for functional testing. For example, the missing path faults. See here, in the whenever we are uh, implementing the system, and whenever we are testing the system or implemented program, and we what we want is our main goal is all the paths in the control flow diagram should be executed, right? But if some of the paths are missed, and whatever the faults exist in those paths cannot be identified. So create the functional test suite first, then measure structural coverage to identify what is missing. See here, as I said, see there is a gap between the control flow strategy and the functional testing criteria, right? So in order to fill the gap between the functional testing and the structural testing, what is the first step we have to use, or what is the first thing we have to do? First, we have to create the test suites for the functional testing. Then By using that, we have to check whether all the test cases covers the structural testing criteria or satisfies the control flow adequacy criteria or not. Then if not, then we have to check what is missing in the functionality testing. Then we have to identify which are the elements which are not executed by using the functional test cases. Then we have to go for identifying or defining the new test cases for the structural testing or the control flow testing criteria. Then we can use those test cases so that all the statements in the program can be executed. So here that is the case they have given, maybe due to natural difference between the specification and the implementation, because as I said, some of the elements or some of the statements which cannot be executed by using the functional testing. Why? What is the reason? Because there is the difference between the specification and the implementation. As you know that users give the number of requirements, according to that the system is going to be implemented. If there is a difference in the specification given or requirements given and the implementation, then it is very difficult to test the implemented program by using the functional testing, because some of the elements cannot be executed or may reveal flaws of the software or its development process. So there exist the flaws when we are implementing or developing the software. So that can be revealed when we are testing the implemented system or the program. Okay, inadequacy of specification that do not include the cases present in the implementation. See, as I said, there is a difference between the specifications given and the system implementation. Then the some of the specifications may be present as some of the specifications given that if those are not implemented and extra thing is implemented which are not present in the specification, then also the testing will not cover all the statements or all part of the program. And coding practice that radically diverges from the specification. So as you know that specification or the requirements will be collected by one team, design will be done by one team, and the implementation will be done by one team. Different team members are there in a different team, and hence there is a gap exists between the specification collected or the requirements collected specification and the implementation, and that cannot be covered just by using a single testing strategy, because due to the inadequate functional test suits, whatever the test cases we have developed or defined or whatever the test suits we have constructed, there may be inadequate. When we say that inadequate functional test suits or test cases, if the test cases are not covering the entire program, then we say that it is inadequate functional testing. Okay, inadequate functional testing. And similarly, if it is a inadequate structural testing, means if it is not covering all the part of the program or all the statements of the program, then we say that the testing is a inadequate testing. Understood what is inadequate functional testing or inadequate structural testing? Inadequate means not all the part of the program is executed. Some part of the program or some statements or some branches are missed. When we are testing the implemented program, then we say that it is an inadequate testing strategy or inadequate testing, inadequate test cases. And the structural testing is more attractive when compared to the functional testing, because of the automated coverage of the measurements are convenient for the progress indicators. Okay, because they are convenient progress indicators when we are testing the system. And the structural testing is sometimes uh, used as the criteria for completion of the entire testing strategy. ಸರ್ ಕ್ಲಾಸ್ ಇದೆ, ಇನ್ನೊಂದು 5 minutes ಮುಗಿಸ್ಕೊಂಡು ನಾನು ಅಲ್ಲಿ ಜಾಯಿನ್ ಆಗ್ತೀನಿ. ಯಾಕೆಂದ್ರೆ ನೀವು 12 o'clock ಕೊಟ್ಟಿದ್ದಲ್ವಾ ಆ ಟೈಮ್. ಕ್ಲಾಸ್ ಇದೆ ಸರ್. ಇಲ್ಲ, ನಾನು ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ ಸರ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ನಾನು ಆಮೇಲೆ ಫೋನ್ ಮಾಡ್ತೀನಿ. ಓಕೆ. So when we're using the structural testing strategies, we have to use those testing strategies with caution, because that does not ensure the effective suits or the test cases. So we should be very careful when we're using that. So as I said, we are using different structural testing strategies or different structural testing methods in order to test the developed system or the implemented program. One such method is called as the statement testing. It is a structural testing method. Okay. Statement testing is a structural testing method. We have four different structural testing methods. One is the statement testing, second one is the branch testing, third one is the condition testing, and fourth one is the path testing. And first structural testing method is called as the statement testing. Okay, so when we're using the statement testing, and here we assumes that all the statements in the program should be executed. Clear? In the statement testing, when we are going for the statement testing strategy or the statement testing technique, our goal is that all the statements in the program should be executed. Then we say that the statement testing meets the adequacy criteria. Okay, statement testing meets the adequacy criteria when all the statements in the program are executed. That is our main goal when we are using the statement testing. Now let us consider the example. Let T be a test suite. Test suite is nothing but the set of test cases. Suppose 5 test cases are present, then we'll combine them and forms the test suite. Okay, so test suite consisting of set of test cases. Let us consider that let T be the test suite for a program P, and say T satisfies the statement adequacy criteria for the program P. For each statement S of program P, there exists at least one test case in T that causes the execution of S. So what it means? So we have the implemented program and we have the set of test cases, and the set of statements are there in the program. Then the statement testing criteria or the test case meet the adequacy criteria only when all the statements in the program are executed by any of the test cases which are there in the test suite. Understood? So adequacy criteria, each statement, or if you consider the node in the control flow. ಸರ್ ಕ್ಲಾಸ್ ಇದೆ, ಒಂದ್ 2 ನಿಮಿಷ ಬಿಟ್ ಮಾಡ್ತೀನಿ ಸರ್. ಓಕೆ ಓಕೆ ಸರ್. ಓಕೆ. Adequacy criteria, each statement must be executed at least once. Or if we consider the control flow diagram, then each node in the control flow diagram must be executed at least once. Then we say that the statement testing meets the adequacy criteria. Understood? So C statement, see, it indicates that C statement is equal to number of executed statements in the program and number of statements present in the program. Now let us consider that the program consisting of 100 statements, total number of statements. There exist 100 statements, and out of 100 statements, if 90 statements are executed, then we say that it is inadequate. Why? Because our goal is all the statements in the program must be executed. Then only we'll say that statement testing meets the adequacy criteria. So C statement is equal to 1 only when all the statements in the program are executed. Suppose 100 statements are there. If all 100 statements are executed, then we say that C statement is equal to 1, and we say that the test suite T satisfies the statement adequacy criteria. Understood? So in the program, if 100 statements are there, and if all hundreds execute, number of executed statements is equal to 100, and total number of statements is also 100, then we say that C statement is equal to 1, and we say that T satisfies the statement adequacy criteria because C statement is equal to 1. Clear? So T is nothing but the test suite. It consisting of set of test cases. Clear? So we say that the statement testing meets the adequacy criteria only when all the statements in the program are executed. Otherwise, we will say that it is inadequate. So a fault in a statement can only be revealed by executing the faulty statement. Say here, if all the statements are executed, if one of the statement consisting of any fault, if that particular statement is executed, then only we are going to identify the fault which is present in the statement, right? A fault in the statement can only be revealed by executing the faulty statement. And now let us consider the test case T0. So here a T0 test case is there. We'll consider this example when this T0 test case is applied on the implemented program. So what is the coverage of the test case T0? The coverage of the test case T0 is 0.94. Why? Because the program consisting of 19 statements, out of 19 statements, only 18 statements are executed by the test case T0, and hence the value is equal to 0.94. Right? So or it is equal to 94%. The statement coverage is 94%, whereas the node coverage is 91%. Why the node coverage is less? Because only 11 nodes are existed in the control flow diagram, and out of 11 nodes, only 10 nodes are covered by the test case T0. And hence the adequacy criteria is 91%, and we say that it is not meeting the adequacy criteria. Why? Because if it is 100%, then only we say that the test case T0 meets the adequacy criteria. If it is less than 100%, RC statement is not less than 1, then we say that it is inadequate. And now let us consider the test case 1, T1. So this test case T1 results in 100% statement coverage. Why? Because all the 18 statements in the program are executed. Then we say that it is 100% statement coverage, or it meets the adequacy criteria. So T1 satisfies the adequacy criteria because it causes all the statements to be executed, and it satisfies the statement adequacy criteria by reaching the value statement C statement which is equal to 1. Clear? Okay, so this is example. Once again they have considered this is the control flow diagram which consisting of how many nodes? 1, 2, 3, 4, 5, 7 plus 4, 11. So 11 nodes are there. Out of 11 nodes, only 10 nodes are covered by the test suite T0, and hence the adequacy criteria is only 91. But if you consider in case of statements, all the statements are not covered by T0, but T1 covers all the statements, and we say that the test case suite or the test case T1 satisfy all the adequacy criteria. And so next we'll move on to the branch testing. So in the branch testing, before that, just okay, statements are blocks. See here, if you consider the control flow diagram, then the statements that we are representing in the form of a nodes are blocks. See here, these are it consisting of series of statements or set of statements, right? And which are put it in the form of a block or in the form of a node, right? So nodes in the control flow diagram often represents basic blocks of multiple statements. See here, multiple statements are present in the block. See, three statements are present here, also two statements, three statements, like this. So each block consisting of multiple statements, or each node consisting of multiple statements. And some standards refers to basic block coverage or the node coverage. So here we can look into the block coverage or the node coverage. And if 100% node coverage is there, then we say that it is 100% statement coverage or the 100% coverage criteria, but levels will differ below 100%. And a test case that improves one will improve the other. See here, as I said, when we're using the T0, it is not covering all the nodes, but when we're going for T1 means we are improving the test cases, and that test case covers all the nodes like that. So some of the test cases covers all the statements or all the blocks or all the nodes, but some of them are not cover all the nodes, right? So if all the test case is not covering, then we are improving the test case so that it covers all the statements or all the nodes, so that we can achieve the 100% adequacy criteria, right? So coverage is not the size. See here, let us consider that coverage does not depend on the number of test cases. Now let us consider that we have the test cases T0, T1 in the test suite. We have the test cases T0 and T1. In another one, we have T0, T1, T2, etc. like that. So we are having the number of test suites, and each test suite consisting of number of test cases. Now let us consider that test suite T1 consisting of 10 test cases and test suite T2 consisting of only 5 test cases. Even the T2 consisting of 5 test cases, but these test cases may cover all the statements or all the blocks in the program, whereas the test suite, even though it consisting of 10 different test cases, but it is failed to cover all the blocks or all the nodes in the system. So hence the size is not depend, or the size of the test suite is not depending on the coverage, because even if the size of the test suite is small, but it may cover all the blocks or all the nodes. So minimizing the test suite size is seldom the goal, because the small test cases make failure diagnosis is easier, and if failing test case in T2 gives more information for fault localization than the failing test case in T1. So here we are not bothering about the size of the test suite. It may be the larger or the minimum one, but we are mainly concentrating on whether all the faults are identified in the program or not. So we are mainly concentrating on the identifying of the faults or the errors which are present in the program, rather than size of the test suite or the number of test cases. So this is about the statement testing, because see here, all statements can miss some cases. Complete statement coverage may not imply executing all the branches in the program. So that we discuss in the branch testing, because even if all the statements are executed, but they may not cover all the branches in the program, that will see it in the branch testing. So in the statement testing, we are mainly concentrating on execution of all the statements in the uh, programs to meet the statement adequacy criteria. So this is about the structural testing and the statement testing. So in the next class, you are going to study about the branch testing. Any doubt? Any doubt, Miss Ba and Sharanya?